All right, so again, we're using the substitution method to find an answer for systems of equations. Graphing was option number 1 for solving a systems of equations. Substitution is option or method number 2. We're going to use substitution when one or more of the equations is not ready to graph. And if we were to go ahead and graph and then they didn't intersect at a perfect blue corner, we'd have to go back to substitution. So when you guys get your professional careers and you have a problem like the quiz today, Lisa in the jewelry making business, when she's trying to find that answer where those lines intersect, substitution would have been a really quick and easy method to use. So the steps for substitution are right here. So you're again writing these on the left side of your notes. So step 1, if necessary, most of the time if you choose to use substitution, step 1 will be done for you. So it says, if necessary, solve one equation for one of the variables. In other words, what's in parentheses, this is the part you need to remember, get one variable by itself. Get one variable by itself. Step 2. Substitute the known value into the other equation. You will get a numerical value. And I know this doesn't make a lot of sense right now, but these steps will prove themselves when we do an example all together. Step 3. You're going to take that answer from step 2 and substitute it into the other equation. Step 3 is very quick compared to step 2. In step 4, now that you have your answer, you're going to plug the ordered pair into both equations to make sure it works. All right, so at this time, we're going to go ahead and do example number 1. So step 1, get a variable by itself. Is that step done for us? It is. We have one variable by itself, and this is a prime example of when we would use substitution. We're not ready to graph this, but we are ready for substitution. So x is by itself. X equals negative 3y minus 2. Go ahead and put that in parentheses because we're going to substitute that chunk in for x. So put both of those chunks in parentheses. So x equals that. We're going to plug it in for x. So algebraically, I cannot work with these two equations by themselves because there's more than one variable. But I can use them together and find a value. So we're going to rewrite this bottom equation. It's going to say negative 4, open parenthesis. We're going to take that chunk and plug it in. Negative 3y minus 2 minus 5y equals 8. So we rewrote that bottom equation. We took what x equaled and we plugged it in for x. So that's the first part of step 2. Now, if you recall, it said step 2, you're going to get a numerical answer. We need to solve for y. I know this looks really big here, but we've solved equations like this. It's all y's, so we can get an answer now. So to get rid of these parentheses, we're going to take negative 4 times negative 3y and get positive 12y. Negative 4 times negative 2, we get positive 8. And we're going to rewrite everything else, which is negative 5y equals 8. So that looks a lot nicer now that we got rid of the parentheses. We're going to go ahead and combine like terms. I'm saying combine like terms because the y's are on the same side of the equation, or the equal sign. So positive 12 and negative 5 make what? Positive 7y. We still have our positive 8, and it equals 8. And then now it's ready to solve. Subtract 8 on both sides. Minus 8 over here. 7y equals 0. Last step, divide both sides by 7. 0 divided by 7 is 0. So that altogether is step 2 to get a variable by itself. Okay, we had a variable by itself, we substituted in, we got a numerical answer. Okay, so we know what y is, we need to know what x is. So step 3 said to take your answer and plug it in to the other equation. And that equation, where x is by itself, that's going to be the easy one to use because you're just going to plug it in. So you're going to take 0 and you're going to plug it in for y. So x equals negative 3 times 0 minus 2. So x is already by itself. So 3 times 0 is 0, and 0 minus 2 is negative 2. So we have two answers. We have an x and a y. We're going to list our answer as an ordered pair. So that's, and then step 4 is to take your ordered pair and plug it in and make sure it works. So if I erase some of that work there, negative 4 times negative 2 is 8. 8 minus 5 times 0, so 8 minus 0 is 8. Okay, so just plug that in just to double check that you have the final answer correct. Okay, so that's one complete problem with all 4 steps. I'd like us to go ahead and try example number 2 together here. Okay, so example number 2. 3x plus 2y equals 10, and y equals 2x minus 9. So step 1, get a variable by itself. Do we have a variable all by itself in this particular problem? Yep, y is by itself, so y equals 2x minus 9. So we're going to take 2x minus 9 and plug it in for the y, because it says y equals. We're going to plug it in for the y. So if we backtrack and look at example number 1, it said x equals, we plugged in for the x. On number 2, it says y equals, we're going to take that chunk and plug it in for y. So when I rewrite that top equation, it's going to say 3x plus 2 times, we're going to replace it with the 2x minus 9 equals 10. Now I want you to notice, again, right here, this is all x's. If you substitute in and you put it in the wrong spot, you're going to get a mixture of x's and y's, and that's going to be a red flag for you that, hey, I need to redo that step. Okay? So again, I have a big equation here that I need to solve. So that first step is going to be to get rid of these parentheses. 2 times 2x and 2 times negative 9. So 2 times 2x is 4x. 2 times negative 9 is negative 18. Once again, we have x's that are on the same side of the equal sign that we need to combine. So 3x and 4x make 7x, and we still have our minus 18 equals 10. So we need to add 18 over to get 7x by itself. So 7x now equals 28. We're going to divide both sides by 7, and the value of x is 4. What questions do you have right now on how we got x equals 4? All right, so I'm going to take my x equals 4. That's my first answer. And step 3 is to plug it back in. You can plug into either equation, but if you plug into the top equation, you're going to have to multiply and then subtract and then divide, okay, to get that y by itself. But if you look here, the y is already by itself, so that's the equation that I suggest you plug into. So we're going to take x and we're going to plug it in right there. And so y equals 2 times 4 minus 9. So that variable is all by itself. We're going to plug it into that one. 2 times 4 is 8. 8 minus 9 is -1. So then my final answer as an ordered pair is 4, comma, -1. Yes, ma'am.
But if you did it with the other one,
You
you get the same answer. So
will.
Is that for everyone?
Yep.
Okay.
Yep. Now to check, take this ordered pair and plug it into the one you just didn't use. 3 times 4 is 12. 2 times -1 is -2. So 12 plus a -2 is 10. And we know that that ordered pair is now a solution for both. So if I was to graph these two equations, what would happen? These two lines would do what? They would intersect at that ordered pair. Okay? So I'm going to give you 2 minutes, and I would like you to see how far you can get on example number 3. Go ahead and start example number 3. example number 3 is not a like super clean problem for you to work through. You won't have one like this on your homework, but this is an example of what a reason why you would need substitution, though, because you could get the exact answer, whereas a graph would not yield the right, or you wouldn't be able to tell, okay, what that answer is. So step 1, we have a variable by itself, and so that is the y equals 2x minus 3. So y equals 2x minus 3, we're going to take that and we're going to plug it in for the y. Okay? So 2x minus 4 times the 2x minus 3 that we're plugging in, and that all equals 7. So distributing, now I did see, let's pay attention to our signs here, okay? So 2x, now negative 4 times 2 is going to be negative 8x. Negative 4 times negative 3 is going to be a positive 12. Combining like terms, we have 2x and negative 8. That is a negative 6. And we still have our positive 12 equals 7. We're going to subtract 12 from both sides. You're going to get negative 6x equals negative 5. Divide both sides by negative 6. And your answer is 5/6. What is the decimal?
Can you solve a negative? Can you do -5 over -6?
Negative over negative, I'd like you to write that as positive so that you don't make a mistake when you plug it in. Now, negative 8.3 or 0.83 repeating, right?
It would just be positive.
Oh, yes, positive. Let me restate that there. So that decimal, we're going to plug this into that other equation. Always plug in a fraction. Okay, if you wrote it in your ordered pair as a decimal, that would be fine. But we want to plug this 5/6 in for the x. Now I know that some of you are not as confident with fractions as you can be. So you would just use your calculator, okay? So you're going to take that x, you're going to plug it in. We're using this top equation. 2 times 5/6 minus 3. Now, if you're using the graphing calculator, you definitely want to do 2, open parenthesis, 5 divided by 6, close parenthesis, minus 3. If I wanted to not use do this without the calculator, I'd multiply straight across. So that'd be 2 times, I'd be 10/6 minus 3. I could find a common denominator there. So 6, I'd have to make that 18. I'd subtract 10 minus 18, negative 8 over 6. And that would reduce to what decimal in your calculator? Negative 4 over 3. And it's negative 1.3 repeating is what your calculator gave you. So that's your y value. So ordered pair, 5/6, comma, negative 4/3, or your negative 0.8 repeating, comma, negative, or positive 0.83 repeating, negative 1.3 repeating. You can. I'm not a fan of mixed numbers, but negative 1 and 1/3 is fine. Yep. All right, so again, that process, you won't get any fractions on your homework most likely, but that is an option there. The rest of these examples are pretty much the same as what's happening here. I will upload a PDF of this notebook into Schoology so you can have all of the answers for all of the examples. But at this time, I'd like you to flip over and I'd like you to look at example 5. On example 5, what I want you to notice here is that we're not ready for step 1, or step 1 isn't done for us. So step one is that we need a variable by itself. Okay? Both of these are close to having a variable by itself. What do you think would be easiest to get by itself? The y in number 5 or the x, or the y in the top or the x in the bottom? X in the bottom, okay? So if I wanted to rewrite this equation, I would subtract 2y from both sides, okay? Now this 2y, it doesn't combine with the 11. They're not like terms, so you're simply just going to have x equals 11 minus the 2y. So that means that you have a variable by itself right here, and we would be ready to then finish out this example. Okay? So again, I'm going to give you 2 minutes, and I'd like you to start this problem. So find your answer for x and y. So we know that x equals 11 minus 2y. We're going to plug that in for x. So go ahead and work on that example. I'm going to go ahead and go through the steps for finding your final answer for number 5. So like we already said, we're going to take this 11 minus 2y and plug it in for x. So that first line is going to look like y minus 3 times the quantity 11 minus 2y equals 2. So we do have a negative 3 that we need to distribute. So we're going to have y minus 3 times 11 is going to be negative 33, and negative 3 times 2, which is positive 6y. So combining like terms, we have a 1y and 6y that make 7y. Minus 33 equals 2. Add 33 to the other side, 7y equals 35. Divide both sides by 7. And y equals 5. So y equals 5 is your first answer. We're going to take that answer and we're going to plug it in to that top equation. Or excuse me, we're going to use this bottom equation that we rearranged. The x is by itself. So x equals 11 minus 2 times 5. And 2 times 5 is 10, so 11 minus 10, and x equals 1. So our ordered pair is 1, 5. And step 4 is to check and make sure it works. So I would go back up here, and 5 minus 3 times 1. So 5 minus 3 is indeed 2, and so we know that that is our correct answer. So again, you guys feel free to start your homework. Otherwise, I'm going, if you want to see more answers or examples, you can find the PDF version of this video in Schoology.